Angles in any position. So we're going to get a little bit more complicated. We're going to get a little bit more in depth. We're going to play in all four quadrants, which we kind of did in the last lesson. This one's going to take a little bit more time. So we'll be good. We're smart people. This I talked a little bit about in the last lesson, that quadrant 1, both x and y are positive. If you go to quadrant 2, x becomes negative, y is still positive. If you're in quadrant 3, both x and y are negative. And if you're in quadrant 4, the x is still positive, but the y is negative. Now, you guys know all this because you've plotted points a million times on a graph. You're good with this. But remember, I know some of us are still struggling with this, but it's always the x coordinate first, then the y in a coordinate pair. And we're going to get really, really good at this. Okay, so we are going to do some math together. Let's pick a point in quadrant 1. And since nobody's here, I'm going to pick point 2 and 4. All right, so over 2, up 4, we're around here. I'm estimating. This is all rough. Okay, so what we can do from this is we can draw a right angle triangle. And I'm just going to grab my handy dandy ruler. So I'm going to put in my vertical line. We know the base. And I'll draw in my diagonal line. Okay, so with this information, we know that there's my right angle, because the vertical will meet a horizontal at a 90-degree perpendicular. So this ties into last year's math. Okay, so here we go. We know the base of the triangle. We do. We know it from this information here. We know that the base, we went over 2 units, so the base is 2. We know that the height is 4. So from that coordinate, we know a little bit about our triangle. What we don't know yet, because we can find it, is our hypotenuse. So we need to find our hypotenuse length. Now, you could solve for an angle and then solve for a missing side, but really what I'm trying to find is the hypotenuse here. So I'm going to use Pythagorean theorem because it's going to save me some time. So these would be my A and B because my hypotenuse is always the C. So I'm going to have 2 squared plus 4 squared equals C squared. 4 plus 16 equals C squared. So we have 20 equals C squared. And so the root of 20 is equal to C. Now, some of you might be saying, hey, Scallion, do I need to simplify that because I know what that is? And that makes my heart so happy if you want to simplify it. But you don't have to here. I think I'm just going to leave the radical stuff kind of on the shelf. Would it be best practice to simplify? Absolutely. But I don't want to get caught up in people making mistakes in simplifying and missing out on the trig. So if you want to simplify and you're confident to simplify, please go ahead and do that. But I think for this lesson, I'm just not going to simplify just so we don't lose the trig in this. So please bear with me. Okay. Another thing is when I'm asking you to leave them as ratios, what I'm asking you to do is leave as a fraction. Okay, so now for this purpose, we're looking for our acute angles. We're looking for our reference angles. So they are measured from the x-axis. So if we know that we're going from the, sorry, you can't see, from the initial arm to the terminal arm. So this here is the angle that we're trying to find. I probably could have made this graph a little bit bigger. So this is our indicated angle. So sine of the angle is equal to the opposite side. So this would be opposite. That would be adjacent. And this would be my hypotenuse. And that we said was root 20. Hope you guys can see that okay, because it's really tiny. I'm going to make it bigger for the next one. Okay, so sine is opposite over hypotenuse. So we're going to have 4 over root 20. That's exciting, everybody. And then we're going to do cos. And I know you're saying, hey, Scallion, we can't leave radicals on the bottom. We need to rationalize this denominator. And I 100% agree with you, but I'm going to say it again. I don't want to get caught up in doing too much chapter 5 stuff here, because if you're not confident with that, but I think you probably all are, if you're not confident with it, it might mess up our trig. So for today, I'm going to give you permission to be not mathematically, grammatically correct. I know, it's a good day to be you. And you're like, can I simplify that to 2? At least let me simplify that to 2. You can, but I'd leave it as 2/1. I wouldn't just leave it as 2. I'm going to leave my stuff not simplified. I'm just living my best life here. Living my best life. All right. You're like, well, that was fun, Scallion. Thanks. And I appreciate your excitement for this. It will all come together, so you just got to bear with me. So what if we moved that same point to quadrant 2? So if we were at 2, 4, now we're at -2 and still a +4. So if I draw on my triangle, there's my triangle. I know my base is -2. Doesn't that feel weird? I have a height of 4. And where is that acute angle? This time it's a reference angle, because I'm not starting there. It's got to be an acute angle, so it's down here. Now, we need to find the hypotenuse, but it should be the exact same as that original triangle, because if we say -2 squared plus 4 squared equals c squared, that -2 is going to turn into a +4 when we square it. So we're going to have that 20 again. So again, we're going to work smarter, not harder. I'm going to tell you a little secret. The hypotenuse will always be positive because we're squaring stuff, and that will turn those negatives into positive. So if we were to do the trig ratio again, here, sine of the angle is opposite, which is 4 over the hypotenuse of 20. I feel like we've seen that before. Let me slide up for a second. Look at that. It's the same here, and it's the same here. This is coming together. Cos is now not a +2. It was a +2 here, but now we're in a different quadrant. It's a -2. Still over a positive root 20, but now this fraction is negative. That makes me sad. And then we have tan, which is opposite, so 4, but over a -2. So my tan becomes negative as well. So sine's the only one that stayed the same. Interesting. Okay, let's pop into quadrant 3. So quadrant 3, our point would be at -2, -4. And so I hope you guys are feeling comfortable with this. We know that their hypotenuse is going to be root 20. Because again, those -4 times -4 is going to give us that +16. So we don't need to redo the math. So we're going to do sine. Sine of that acute angle. And it's here, or that reference angle, because it's always against the x-axis. So it has to be there. So this is going to be opposite, which is -4 over root 20. Cos is -2 over root 20. Hey, that's the same as quadrant 2. And tan is going to be -4 over -2. Now this is where I'm going to get grammatically picky about this. We never want to write something with 2 negatives in it. That's just bad, because I want to know that you understand that that's equivalent to 4/2. Okay, exciting stuff. Your mind's blown. Maybe not yet. All right, so if we flip this to quadrant 4, if we flip our point to quadrant 4, so 2 and -4, 2, -4. Again, my angle has to be made with the x-axis. So my 2's gone back to positive, my 4 stays negative. but my hypotenuse is still root 20. Because like, Skyline, these are all the same numbers. I don't know why we're doing this. Give me a second. I promise it's coming together. So sine of the angle is -4 over root 20. Cos of the angle is positive 2 over root 20. And tan of the angle is -4 over 2. And you're like, okay, great, thanks. You took us down all 4 quadrants and I don't really understand what this means. Okay, so in the unit circle, in trig, in different quadrants, it's really important to know where the trig ratios are positive and negative. And so we have something called the cast rule. And the cast rule tells us what trig ratio is positive. Okay, so we know that this is quadrant 1, this is quadrant 2, this is quadrant 3, and that's quadrant 4. And again, I'm not tied to the Roman numerals. If you want to label them, I think it's Arabic numbers, 1, 2, 3, 4, that's fine, no problem there. Okay, so maybe let's work backwards. In quadrant 4, what trig ratio is positive? What fraction is positive? And hopefully cosine is jumping off the page at you. So we know that in quadrant 4, cosine is positive. Pretty exciting stuff, I know. If we slide up all the way here, what trig ratio in quadrant 3 is positive? Tan is positive. So I'm just going to slide back down here. All right, now we got to flip backwards in our pages. Hold tight. If we look at quadrant 2, which one's positive? Sine is positive. And while we're on this page, just so we don't have to flip back and forth, in quadrant 1, all of them are positive. All are positive. Okay, so if I go back and I go back to my cast rule. All right, so the reason why we call it the cast rule is because it spells out cast. So in quadrant 1, if you have an angle that terminates in quadrant 1, your ratios will all be positive. Terminates in quadrant 2, sine will be positive. Quadrant 3, tan will be positive. And quadrant 4, cos will be positive. And you're like, that again, great, Scallion, I don't get where this is going. It's all going to connect, but this is a cool way to remember which trig ratio is positive in each one. Okay, here we go. All right. You know those reference angles that we did the other day, yesterday? Those are kind of important. Okay, so this is what we're going to do. Using a reference angle to solve for your theta, to solve for that angle in standard position. So this is where actually all the pieces are coming together. So in quadrant 1, so this is angle in standard position. So it's like your real angle. Like, I don't know how else to say that. Like, it's the one that we're measuring. It's the important one. The angle in standard position is the theta. The theta r is reference angle. So in quadrant 1, they're the same thing because they're acute. They're less than 90 if they're in that first quadrant. In quadrant 2, and we did these rules yesterday when we did that example. We just did them without making them a rule. It's super easy. We're going to find our reference angle. We're going to subtract it to 180. Easy peasy. In quadrant 3, our angle is made up of 180 plus our reference angle. This quadrant 3 is the only one that has an addition sign in it. Quadrant 4, you're going to take 360, you're going to minus your reference angle, and ta-da, quadrant 4. These you're going to have to memorize. They are not on your formula sheet. They are a little bit more complicated than just the secret formula or the not so secret formula. You need to know them, but guys, you don't need to, okay, maybe memorize isn't the right thing. You guys, if you understand this, these rules make sense, and maybe you don't need to memorize them because you can find them. You're like, I don't get what you're saying, but trust me, go with me on this one. We're going to do an example, and hopefully that will be helpful. Okay, so the point -5, -12 lies on the terminal arm of angle theta in standard position. Determine the exact values of sine, cosine, and tangent. Okay, so if I'm asking for sine, cosine, and tan, I want to leave it as a fraction. So essentially, we're just doing that example. So our point, if both are negative, we're in quadrant 3. You're going to get better at this. You're going to start linking things you already know and going a little bit faster. So you're already good at plotting points. We're just linking them now to math. So -5, -12. I'm going to be in quadrant 3. So we'll say I'm down here somewhere. -5, -12. Okay. That's supposed to be a right angle triangle, but you get the idea. My reference angle will always be against the x-axis. We know that the base of this triangle will be -5. We know the height of the triangle will be -12. What do we need if we're going to find the exact values of sine, cosine, and tangent? Sine and cosine need the hypotenuse. So we need to solve for the hypotenuse using Pythagorean theorem. We know the hypotenuse will always be positive because we're going to square some stuff. So we're going to have -12 squared plus -5 squared equals c squared. So 144 plus 25 equals c squared. 169 equals c squared. And I left myself not enough room because that's who I am as a person. This is a perfect square. And again, depending on how comfortable you feel with numbers, you have your calculator. I know that if I take the root of 169, it's a perfect square. So C is equal to 13. So let me draw that in. That's 13. Just switching my colors so we can see it. So the hypotenuse has a measurement of 13. And remember that the hypotenuse will always be positive no matter what quadrant you're in. It's always going to be positive. So now we're just doing the trig ratios. Sine of the angle is equal to the opposite side, which is -12 over 13. Cos theta is equal to the adjacent side over the hypotenuse. And tan is equal to the opposite over the adjacent. Now, you would not leave that as -5 or -12 over 5. You're going to rewrite that, or you're going to use a handy eraser, and you're going to get rid of these. I don't want to see this. I want to see it written as a positive. And that's all that question is asking you to do. It's pretty nice, pretty straightforward. And I kind of rushed through that one. I didn't label my sides. I didn't do anything like that. But I think that we're pretty confident in putting our trig ratios together, labeling our sides, or we should be. And if you haven't quite mastered that yet, then I would encourage you to go back and label all the sides to your triangle before you do these ratios. And I've been doing it for many years, so I know my ratios like the back of my hand. We're not going to do this example here. I know you're all disappointed. Okay, I'm going to flip the page. I feel like I'm rushing through this one. I think you guys would agree. I'll try to slow down. All right. Suppose, oh, this is a good one. This is going to be on your quiz. Somebody put a star beside this. Okay, suppose theta is an angle in the third quadrant. In the third quadrant. And we know that cos of the angle is equal to a -3/4. What are the sine and tangents of this angle? So, seems like you don't have enough information, but that's okay. What do we know? We know that that's my adjacent side. We know that that's my hypotenuse. What do we know about hypotenuses in any quadrant? We know they are positive, okay? We know they're positive. So really the way that could be written is cos theta is equal to the -3 over a +4. And I'm always going to write them like this because I'm not going to tell you where that negative should live. But we know that hypotenuses will always be positive. Okay, so what we know is this is in the third quadrant, so you need to know where the third quadrant is, but luckily you've all been paying attention, and quadrant number 3 is down here. So we're going to draw in our triangle. What do we know? We know this side's 4, and if we know angle here, what do we know where's -3? Is -3 my base or my height? So let's go back to this. We know that cos, let me grab a different pen. Oh, I did it already up here. This is my adjacent side. So where's my adjacent side on this triangle? My adjacent side is here. So if I know that's my adjacent side, what I need to find in order to do it is my opposite side. So again, we're just going to use Pythagorean theorem. So it's like that before you were putting them on, and that's kind of the mechanics of it. Now this is the application of it. You're taking that information and you're applying it. So this time we have the hypotenuse and we have one of the sides. So we're going to have -3 squared plus b squared equals 4 squared. So 9 plus b squared equals 16, minus 9 from both sides. So b squared is equal to 7. And again, didn't leave myself enough room. So b is equal to the root of 7. Root of 7. Okay, so now I can do the trig ratios for the other two. I have the trig ratio for cosine. It was given in the question. So now I'm going to do sine. So sine of the angle. And first of all, look, I put that as a 7 because I'm so used to doing positive principal roots. But where am I on the coordinate plane? I'm in quadrant 3. So I know that both the x and the y are negative. So I have to be smarter than my math. And I have to make sure that that's represented by a -7. Because we're in quadrant 3, so both the x and the y have to be negatives. So this is going to be -√7 over 4. And tan is going to be opposite, which is -√7 over adjacent, which is -3. And oh my goodness, can I write it like that? No, I can't write it like that. So that's going to be √7 over 3. And like if you guys write it like this and you're doing it in pencil, I'm just not doing it in an erasable pen. Just erase those. Like don't rewrite it. Just erase them. I'm using pen, so it's not really working all that well. Okay. So now you're going to have to just either pause the video, take an emotional break from this, because this is where things are going to get complicated and without a picture. Okay, big deep breath in. We can do this. We are smart people. Okay. And so before you start saying, I can't do this, I don't know where I am, I'm not going to try, I would encourage you to try to practice the assignments, work with somebody, talk it through, go see another teacher. What I need you to do is not give up. Just because I'm not here, you guys are resilient, you are smart people, you can do this. I know this is new and I know it's hard, but once you get the hang of it, it's not that hard. Anything new feels uncomfortable, but we've got to practice it so we become better at it. Okay, so easy peasy. Scallion, this is an easy question. I got this. Why isn't everything this easy? Okay, I turn on my calculator and I'm going to go, okay, I need to solve for theta, so I'm going to go second function sine, 0.5, ta-da, 30 degrees. I'm done. Check. Yay. Okay, you're almost done. You found the first angle. But what you need to remember is your cast rule. This is a positive decimal. Now back when you were in grade 10, you lived in triangles. Now you're living on the coordinate plane. You need to go to your cast rule because sine is positive in two places. If you go back to your cast rule, here, let me just draw this here because I know my cast rule. So where is sine positive? You just found that 30 degrees. Sine's positive in quadrant 1, and sine's positive in quadrant 2. So the first time in your life, I'm asking you to look and see beyond just a basic triangle. All right, so in quadrant 1, it's pretty easy. In quadrant 1, you know that the ratio is 0.5. You're gonna do exactly what I did in my calculator. So, I'm gonna label these. I'm gonna do them quadrant 1. And so in quadrant 1, it's really straightforward. Sine theta is equal to 0.5. And I told you how to write the notation for it. There you go. And this is also going to be on the quiz. So take a big deep breath in. This is definitely going to be on the quiz. So that's great. You've solved half of it. Now we got to talk about quadrant 2. No, I was doing theta. Let's go here. Quad 2. So now we're in the second quadrant. And this is where the rules come in. Do you guys remember the rule for quadrant 1? Let me grab a sticky note. Maybe this will be helpful. And maybe this is what you guys want to do. Grab a sticky note and put them on here. So theta equals theta reference. Theta equals 180 minus theta reference. Quadrant 3 is the only one with an add sign. And maybe you want to put them on a sticky note so that you can move them around, take them from place to place. And you guys know that this is quadrant 1. Oh, you can't see that. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Sticky notes are on my desk. I'll leave a stack. So if you have any questions or you want to do that, if that makes more sense to you to have that floating around. So when we get to quadrant 2, I don't know where I'm going to put this for right now. I don't know where I'm going to put it. I'm going to put it up here. So that's quadrant 3 and 4, which is kind of useless. When we get to quadrant 2, we know that we need to use a reference angle. The rule is going to be theta equals 180 minus theta reference. And you're like, well, what's theta reference? Do I have to do more math to find theta reference? And the answer to that is no, because what do you know about quadrant 1? In quadrant 1, theta is theta reference. So you actually already have the reference angle. You already have it. You found it. Because if you found it for quadrant 1, it is the reference angle. So you can just go ahead and use that for quadrant 2. So here's one of my answers. And then I'm going to say 180 minus 30 is 150 degrees. That's my second answer. You need both of those answers to get full marks for a question. Okay, so I'm just going to slide my handy dandy calculator over here. Now, to prove to you that this is true, if I say sine of 30 degrees, I should get 0.5 in an answer. Ta-da! Right? Because that was the question. If I substitute 30 into there, I should get 0.5, which I did. Yay me! But watch this. If I do sine of 150, which was my other angle, if this is meant to work, this should also give me a half. And it does. So you have just advanced into all 4 quadrants, whereas in grade 10, we just kind of gave you triangles and said, don't worry about it. There's a bigger world out there, but you'll get there. And now you're here. So now you're looking for answers. There's more than one place that sine of an angle equals 0.5. No other places, just those two. You won't find another one. Okay, here we go. I have my reference angles up here. All right, so this is negative. So where is cos negative? Well, if I go back to my cast rule, remember that the cast rule tells us where they're positive. So if it's positive in 1 and 4, we know that it has to be negative in the other two. So it's going to be, my answers are going to be in quadrant 2 and quadrant 3. That's where my answers are going to be. So that cast rule can tell us both positive and negative things. Okay, so, but this one didn't have an answer for quadrant 1. So how do I find my reference angle? Because I need my reference angle to solve for those. So step 1, you have to find reference angle. Okay, so you're going to solve the reference angle by dropping the negative. So you're going to go cos of theta r equals root 3 over 2. That puts you back in quadrant 1. And we know that that's where we can, that's going to give us our reference angle. So super easy. We're going to do this all in one foul swoop on our calculator. So reference angle is equal to cos negative 1 root 3 over 2. All right, so second function, cos root 3, and I need to get out from under there, divide by 2, and I'm going to close my brackets. Sorry guys, that's hard to see. And I'll hit equals. Oh, I got 30 degrees again. This is handy. So my reference angle is 30 degrees. So I've just solved for my reference angle. So now I need to use my rules from quadrant 2 and quadrant 3 to get my answers, my real answers. This is a helper. My real answers are going to be in quadrant 2 and quadrant 3. So I'm going to use my reference sticky note. So in quad 2, the rule is theta is equal to 180 minus theta reference. So I'm going to have 180 minus 30, and I will be at 150 degrees. And then in quadrant 3, theta reference is equal to 180 plus theta r, so it's going to be 180 plus 30. And so I will be at 210 degrees. So my two answers are 150 and 210. This is a helping angle. It is not the correct answer. These two are my correct answers. Okay, all right. We can do this. We're smart people. We'll do two more, and then that's it for this lesson. I know it was a little bit long and I went a little bit fast, but you do need to practice it. This isn't going to work if you just say, I don't know. Go back, rewatch the video, ask a friend, ask another teacher. Use your resources. Okay, we just did where cosine was negative. If it's negative, we know our answers are in quadrant 2 and quadrant 3. Mescallion, do we need to indicate that every time? Absolutely not. But step 1, we need to find our reference angle. And we do that by dropping the negative. So cos of theta reference is equal to 0.6753. And so theta reference, and you can do this. You don't even have to show that cos negative 1 line, but you definitely need to know to put it in there. You're gonna get a decimal this time. Let's go 2 places on the decimal, just to make ourselves feel uncomfortable. All right, so the rule for quadrant 2, theta is equal to 180 minus theta reference, which is 47.52. I guess I could have done that in my head, but why would I? 132.48. See? I do it like you guys. I'm like, if I got a calculator, I'll use it. No shame in that. And I need my degree symbols because I'm using degrees in this, so my answers are those two. This is not an answer, it's a helper. So if you're in quadrant 1, if something's positive, then it is an answer and it's a helper. It's double duty. But sometimes we don't do that. Okay. Oh, sorry, you're probably still copying and I'm still sliding. Okay, I'm going to slide over for a second. All right, now we're dealing with sine, and we haven't dealt with sine before, so I'm going to get my cast rule out again. There's a green pen since I've been using blue all this time. So we're looking where sine is negative. So if we know that sine is positive in quadrants 1 and quadrants 2, we know that it's negative in 3 and 4. So we know our answers are going to be in quadrant 3 and quadrant 4. I always write those down just to help me remember which ones I'm doing, because you get tired, you forget stuff. Okay, so we're going to find our reference angle. And we do that by dropping the negative. I'm going to say that a million times because I think that's one of the most common mistakes you'll make. So we're doing sine of theta equals 0.8090. So theta equals, it's not theta, it's theta reference. Ooh, messing up already. Okay, now this one, that's a little bit weird. If we go to 2 decimal places, it's going to round up to 54 because the 8 will round the 9 will round that 9, and that 9 will round that. So the way we're going to write it is 54.00 degrees. Seems silly because, well, they're zeros, you don't need to put them there. But if I tell you to round to 2 decimal places, both decimal places have to be represented. Okay? I just do this to cause you grief. Okay, so for quadrant 3, let me grab my sticky note. For quadrant 3, the rule is 180 plus theta reference. 180 plus 54. So we are going to have 234.00 degrees. And the answer for quadrant 4 is 360, that's supposed to be a 6, minus theta reference. And of course, there's a hole right in the page where I want to write my answer, so I'll go down a little further. And so we're going to be at 3, that's not a 3, that's a 5. 306.00 degrees. And so these two are my answers. And if you want to check to see if they're right, then do sine, like how do I check to make sure this is correct? We're going to do sine, where's my sine button? Sine of 306 degrees. And we're going to get that decimal, the negative 0.8090. Now we had to round some stuff, so we're not going to get it exactly, but you know that you've done it correctly if these answers get you back to that. So it's a good ability to check, right? You do not have to show me the check. It's just if you're doing this on a test or a quiz, did I do this right? You can check it yourself on the calculator. Okay, sticky note might be helpful for your rules. And yeah, that's it. That's a lot. You can use the rest of the period to work on this, and you have a work period tomorrow too. So really important that you do work with somebody and practice this. It will be on your quiz. So we'll see you on Tuesday. I'm sorry I left you for a week. Have a great day, guys, and we'll see you soon.